In this video, I'm going to present you what we call the MIT, the minimum ignition temperature. This feature has a very important influence on a dust explosion. We can dissociate two kinds of MIT, the MIT layer and the MIT cloud. Let's start with the MIT layer. It is the lowest temperature of a surface at which a dust layer resting on the surface can self-ignite. This is usually given for a 5 mm layer, but it will decrease for thicker layers. The MIT layer, or the smolder temperature, describes the flammability behavior of a flat dust layer on a hot surface. It is defined as the lowest temperature of a heated freestanding surface, which is capable of igniting a 5 mm thick dust layer. The thicker is the layer, the lower is the smoldering temperature. Now let's talk about the MIT cloud. Actually, the minimum ignition temperature cloud is the lowest temperature of a hot surface that will cause a dust cloud, rather than a dust layer, to ignite and propagate flame. The test follows the EN 50281. Approximately 0.1 gram of combustible dust is placed in a dust holder at the top of a temperature control furnace with an open bottom. The dust is dispersed by compressed air downwards past the hot surface of the furnace to see if ignition occurs and flames are produced. If the dust does not ignite, the furnace temperature is increased and the test repeated until ignition of the dust occurs. For items of plants, such as dryers, testing the minimum ignition temperature is important to prevent a dust explosion occurring through contact with a hot surface. The internal temperature is generally limited to 2/3 of the MIT when measured in degrees Celsius. For example, a dust with a MIT of 450 degrees Celsius would require maximum operating temperature in the drying process of 300 degrees Celsius, giving a safety margin of 150 degrees Celsius. We thank you for your attention. Stay tuned.